Welcome back. In this module, we have been working on the Chennai house price prediction problem, and so far we have worked around the univariate analysis for the features, and we also did some data manipulation part in the last video. Now in this video, we are going to focus on the bivariate analysis for the same variables, and we have already seen the data set, and by now we are familiar with the variables that we have. So we have broadly divided the variables into three subcategories, which is house related features, the surrounding and locality related features, and finally the house sale price and the commission related features. So here are the columns for our data set, which is DF. And remember, we listed down a few hypotheses about what should and what should not affect the sales price in terms of the features of the house and the locality. So in this video, we are actually going to verify our hypothesis. And I'm going to start with working around the house related features. So these were our house related features, and I had a hypothesis that the interior square feet area of the house should affect the sale price. So if the area is more, then the sale price should be higher for a particular house. So let's see if that is actually true. And here I am creating a scatter plot between the area of the house and the sales price. So as you can see, there is a linear relationship between the area of the house and the sales price, and we can see that for a higher area of the house, the sale price is higher. But for this particular bracket, if you notice, for 1500 square feet and 2000 square feet, we can see that there is a broad range. So now can you think of some of the factors that might be affecting this price range? Like there are a few houses with lower price range, and then there are a couple of houses which have a very high sale price, like above 2 crores. So is there any particular reason? Well, what I can think of is this may be due to the house type. For instance, if it's a commercial house, or if it's a house, or is it a shop or something. And this might also be affected depending on the locality of the house, let's say. So these are a couple of things that I have in mind. Let's try and look around about the type of the house, if that actually matters. So here I am going to create a plot in which I'm going to use both the variables, the interior square feet of the house and as well as the house type or the building type, right? So here we have a function wherein I am creating a plot and I've assigned colors to the different building type categories, which we had commercial, house and others, as we have already seen in the univariate analysis. And then I am using the dot apply function again. So as you already know, for this particular variable, it's going to pick up every row, and the dot apply would use colors, which is this dictionary defined here, for every row on this particular feature. So that's how the apply function would work. And it has given me the following output, where as you can see, the different house types are marked by different colors. So I have green, which is marked for others, which is scattered around. And as you can see, commercial is the top block that we saw here. So that's the reason that commercial houses with the interior area to be 1500 to 2000 square feet have a higher price as opposed to the houses with the same area. Alright, so moving on, let's see if the number of rooms and bedrooms actually affect the house price. That was one of the three hypotheses that we listed. So here I'm going to create a pivot table, and I'm going to collect the median of the sales price for the number of bedrooms and the number of bathrooms. So here I've taken two variables, and hence this is the table that we get. We have the number of bedrooms on this side and number of bathrooms on this side. You can obviously switch both of these, and we can notice that there are some nan values. So from this you can make an inference that there is no house which has only one bedroom and two bathrooms. Also, there is no house which has 3 or 4 bedrooms and only one bathroom. And that sounds about right. And we can clearly see that as the number of bedrooms here increase, the price is increasing. So I can say that the hypothesis that we listed, that the number of rooms and bedrooms should affect the price, and that's true. Now there was another variable which was very interesting, which talked about the quality score of the house. So we had a variable which gave us the overall quality score, and I want to find out if that variable affects the sales price. So here's a scatter plot between the quality scores and the sales price. And as you can see, for a wide range of quality scores, the sale price of houses is dispersed and we cannot see any particular trend. although there is a lower density on higher sale price, but we already know that there are less number of houses with this sale price, and hence that is affecting the density. Otherwise, there is no clear distribution. And if we go ahead and check for the quality scores for the bedrooms, bathrooms, the rooms, and the overall score all together, for that we can create a subplot. So for this subplot, I am comparing the quality score for bedroom against the sales price. The same goes for bathroom and the sale price, etc. And we have set the titles to identify which of the plots belong to which of the categories. Right, so if we have a look here, we can see the same trend here. There is no particular relationship that can be seen from these plots. So the houses of different quality scores have different sales price. And if we compare these four variables amongst themselves, so here's a box plot to do that, and we can see that this quality score distribution for houses for the quality score of bedrooms, rooms, and bathrooms is almost the same. While there's a slight difference in case of the overall quality score of houses, about 50% of the houses lie between approximately 3.2 and 3.7 quality score, and the rest 25 above 3.7 and below 3.2. So that's all you can get from this plot. Now, we looked about the building type and the sale price along with the interior area in a previous plot. Let's go ahead and create a table to identify what is the average sale price for different building types. So we can clearly see that commercial has a very high sale price, while houses and others have a comparatively lower sale price. And it was evident from the plot that we created here. So commercial has always fallen in a higher sale price range, and the two categories, others and houses, are in the lower sale price range. Alright, so let's see if the area around the house or the locality of the house also affects the sale price for individual buildings. So first I'm going to try with building type commercial and setting a particular area Anna Nagar, and let's see the distribution. So we can see that there is almost no house which has a sale price less than 1 crore 60 lakhs, and most of the commercial houses in Anna Nagar have a very high sale price. If we check the same for the building type house, then we can see that most of the houses do have a high sale price, but it's still less than 1.5 cross 10 to the power 7, of course. So that's all about the house related features. Now let's go ahead and explore the surrounding and locality related features. So we saw how building type affects the sale price. Now let's say if the building types have additional facilities like the parking facility, for example. Let's say if that also affects the sale price. So let's run this cell. And here I'm again using group by, and I've specified two categories, the build type and the parking facility. So for commercial buildings with and without parking facility, there is a small difference in the price. And in fact, for all the categories, we can see that the buildings with the parking facility have a higher price range as opposed to the buildings without the parking facility, and that sounds about right. For this example, we have two variables and both of the variables have multiple categories. So instead of comparing these numbers here, let's create a plot. Here I've defined temp, wherein I'm storing the group by results that I just got. And I'm going to use temp.plot and specify the kind of plot to be bar. Right, so here's the plot. We have the values for commercial house type and no parking facility, commercial house type and a parking facility, and we can clearly see the difference in the sales price. Now let's compare the area-wise sales price for the houses. So we already know that there are 7 different areas in our data set. Let's go ahead and compare these using a pivot table. Also note that pivot table and group by are the same functions. They do the same thing and they show the same results. It's just that pivot table offers you a little more functions, but it's basically the same thing. So here are the different area types that we have and the sales price against them. We can see that Anna Nagar is the most expensive and also T Nagar is the most expensive, and Karpakkam looks like to be the least expensive of all the areas. Now let's create sales price plots for different areas. So here I have a plot for Karpakkam, and you can see that the value range is slightly lower because our maximum value went up to 2 crores. Now let's do the same for Anna Nagar, and we can see that the scale has a very huge difference. Here there are a lot of houses which have values higher than 1 crores, whereas here you can see that there are only few houses. Now let's take up another variable. We had a variable distance from the main road, and I believe that distance from the main road should be an important factor and that should affect the sales price of the houses. So let's create a scatter plot between the distance from the main road and the sales price. And you can see that for different distances on the main road, the sale price distribution has no trend as such. And that's quite surprising. So, what do you think if distance from the main road does not affect? Is there any other factor that should be playing a role here? Well, if you look at all the variables that we have, you would notice that we have a variable street, which basically gives us the street type for the houses. And let's see what is the sale price around different street categories. So we have three categories: gravel, paved, and no access, which might mean that these houses do not have good roads and good access. And it's clearly visible that these houses have comparatively lower sale price. Now let's look at the third category where we have features like commission and sale price. Let's create a scatter plot here and we can see that there is a linear relationship. So for lower sale price, we see that no houses have a commission beyond this point, right? But for higher sale price, we can see that there is a wider range, and that actually makes sense because for a house which has like a 50 lakh price, nobody would give a commission of say 60 lakhs. So obviously for the lower sale price, there is lower commission, and for higher sale price, the commission varies, and these lines may be because of the different areas or again the different building types that we have. So this is something I would want you to verify at your end. Again, use the colors, different colors for different categories in the building type, and in fact you can do that for different area or locality as well, and then see if that actually makes a difference. Let's check the correlation between these two variables because this looks like highly correlated variables. And here, as you can see, we have a correlation of 0.62, which is actually very high. So here we learn about a bunch of new plots that we can use to perform the bivariate analysis. I would encourage you to do that at your end and list down some more hypotheses, and using these bivariate analysis and plots, find out if your hypotheses were right or not. Thank you.